Welcome, everyone, to techdaily.ai. We're about to embark on quite a deep dive today into a topic that, well, it touches nearly every business, every individual, really. Cloud security. As more and more of our lives, our work shifts to the cloud, figuring out how to keep our digital stuff safe isn't just, important anymore. It's absolutely critical. This deep dive is sponsored by Stonefly. They're your trusted solution provider and advisor in enterprise storage, backup disaster recovery, hyper-converged solutions for VMware, Hyper-V, Proxmox clusters, even AI servers. Also, SA365, which is a turnkey security appliance, plus public and private cloud solutions. You can check out all their offerings at stonefly.com for more info. So today our mission really is to cut through all the noise and shortcut you to being properly informed on cloud data security, especially when you think about the stakes. I mean, did you know the average cost of a data breach is projected to hit, $4.88 million in 2024?
Yeah, it's a staggering number.
It really is. That's not just a figure on a page. That's a serious hit for any business.
Yeah.
So to kick us off, what's the sort of fundamental shift we need to get our heads around when we talk cloud security?
Well, what's really fascinating, I think, is just how fast everything is changing. It's evolving so quickly. We're not just talking about protecting data like we used to, build a wall around it. We're seeing this fundamental shift in how organizations think about security, moving away from focusing purely on the infrastructure, like the servers and networks, to being truly data-centric, putting the data first. And right at the heart of this, and honestly where a lot of problems start, is this concept called the shared responsibility model.
Ah, the shared responsibility model. Yeah, I hear that term a lot.
You do, and it's crucial. Think of it maybe like renting an apartment. The landlord, they're responsible for the building itself, the roof, the main pipes, right?
Sure, the structure.
Exactly. But you, the tenant, you're responsible for locking your own door, securing your valuables inside, maybe not leaving the stove on.
Right, okay. I get that.
Similar in the cloud. The provider, AWS, Azure, Google Cloud, whoever, they secure the underlying stuff. The physical data centers, the networks, the hardware. But you, the customer, you are responsible for securing your data, your applications, and this is the key bit, your configurations within that environment. Getting that division of responsibility wrong or just not understanding it fully, that's a major, major risk factor.
Okay, that landlord-tenant analogy really clicks. Yeah, It makes total sense why companies might trip up if they just assume the provider handles, everything. But okay, before we jump into the solutions and how to lock that apartment door, let's understand the building itself a bit better. What exactly is cloud computing fundamentally, and what are the big risks that come with putting our data there?
Right. So at its core, cloud computing is just delivering computing services, things like storage, databases, server, software, analytics over the internet. Instead of owning and running your own data center, you essentially rent these resources as needed from a provider. Now, how you interact with these services usually falls into three main models. You've probably heard the acronyms.
IaaS, pieces, FALIS. Yeah.
Exactly. So IaaS, infrastructure as a service. That's where you get the basic building blocks, virtual machines, storage, networks. You control the operating system, the apps, so you have more control, but also more security responsibility. Then there's PaaS, platform as a service. This gives developers a platform, tools, databases to build and run applications without managing the underlying infrastructure. The provider handles the OS, middleware, etc. And finally, SaaS, software as a service. This is probably what most people use daily. Think webmail, CRM software, office suites online. The provider manages pretty much everything. You just use the software.
Got it. So different models, different levels of control, and I guess that means that shared responsibility line shifts depending on which one you're using.
Precisely. The line moves.
And with all that flexibility, that convenience, comes a whole new set of worries, right? It feels like every advantage potentially opens up a new security headache. What are the really big, almost universal risks we see?
You're spot on. The line shifts, and so do the ways attackers try to get in. Cloud definitely removes some old headaches, but it absolutely introduces new significant risks. If I had to pick a few key areas, the first is just a general expansion of your attack surface. Simple as that. Moving more things to the cloud means more potential entry points. Every service, every connection point, every API adds to the landscape an attacker can probe.
More doors and windows to check, basically.
Exactly. And that expansion leads directly to the big one. Data breaches, unauthorized access. And often, it's not because the provider's core infrastructure failed. It's usually down to things like misconfigurations, stolen credentials, vulnerable applications that the customer deployed. Think about this stat. At least 80% of data breaches in 2023 involved data stored in the cloud. That tells you where the battleground is right now.
80%.
Yeah.
Wow.
And the main culprit, very often it's Incorrectly configured cloud settings, simple mistakes, storage buckets left open to the public internet, identity and access management, IAM policies that give way too much permission, basic stuff often. Gartner actually predicts that by 2025, something like 99% of cloud security failures will be the customer's fault.
99%. That's almost unbelievable. It really hammers home that your responsibility part of the model, doesn't
It
it?
really does. It highlights the human element, the configuration element.
Okay, so beyond those configuration nightmares, what else is keeping security teams awake at night when they think about their cloud environments?
Oh, there's more. A massive one is insecure APIs. APIs are like the glue holding cloud services together. They let different applications talk to each other. But if those APIs have weak authentication or don't encrypt data properly or don't validate inputs correctly, they become wide open doors for attackers. We saw something like 92% of organizations had an API-related security incident just in the past year. That's huge.
92%.
Yeah. And related to that is account hijacking. Attackers getting hold of legitimate user credentials, maybe through phishing, maybe malware, just logging in. Cloud account threats apparently jumped 16-fold in 2023 alone. 16. Shows how attackers are focusing their efforts.
That's terrifying. So they just walk in the front door with stolen keys.
Pretty much. And then there are the more insidious risks, like the lack of cloud visibility. Cloud environments change, so fast servers spin up, spin down, new services get added. That dynamism can create blind spots. It's hard to keep track of everything, hard to spot threats or misconfigurations in real time. Combine that lack of visibility with insider threats, employees, contractors, partners misusing their access, either accidentally or on purpose.
Right, the ones already inside the castle walls.
Yeah, exactly. They often bypass your perimeter defenses. And all of these things, if not managed, can quickly lead to serious compliance violations, GDPR, HIPAA, PCI DSS, you name it. Which means hefty fines, reputational damage, the works.
Okay, that's quite a list. It paints a picture of the cloud being incredibly powerful, but also, yeah, a complex minefield if you're not careful, especially with human error and visibility being such big factors. But, okay, here's where it gets interesting, right? Because many of these risks, maybe even most, can be tackled. They can be mitigated, even prevented with the right strategies. So let's talk foundations. Let's start with two absolute pillars, encryption and access controls, like the reinforced walls and the high security locks on that apartment we talked about.
Precisely. Those are the absolute fundamentals. Let's start with encryption. Honestly, It's just non-negotiable for cloud data security, period. It's vital for privacy, obviously. It's required by many compliance standards, GDPR, IPA, NIST guidelines, because all mandate it in various ways. And the core benefit is simple. Even if someone does manage to steal your data, if it's properly encrypted, it's useless to them. Just scrambled nonsense.
Making the stolen goods worthless.
Exactly. Now, we usually talk about encryption in two states, data at rest and data in transit. Data at rest means protecting data when it's just sitting there stored in a database, on a file system, in object storage. This typically uses strong symmetric algorithms like AES 256. Many cloud providers like Google, for example, actually encrypt customer data at rest by default using AES 256, often in multiple layers, so you get a good baseline.
That's good to know that some of it's handled automatically.
It is, but you still need to understand it. Then there's data in transit. This is about protecting data as it moves across networks, between servers to users, between cloud services. This typically uses TLS, transport layer security, that's the S in the HTTPS that you see in your browser. It encrypts the connection, preventing eavesdropping or tampering while data is moving.
Okay, so encrypt it when it's sitting still, encrypt it when it's moving. What about the keys? If encryption locks the data, the keys unlock it. How do we protect those?
Yes, key management. This is critical and sometimes the trickiest part. Your encryption is only as strong as the protection around your keys. For high security, organizations often use hardware security modules, or HSMs. These are dedicated physical devices designed to securely generate, store, and manage cryptographic keys. Very robust. Cloud providers also offer sophisticated key management services, often called KMS. Google's approach, for instance, involves multiple layers. Data encryption keys for data chunks, wrapped by key encryption keys, all managed within their key store and protected by master keys. And crucially, they often let you choose. Use keys managed entirely by the provider, which is easier, or use customer-managed keys, CMK, or even customer-supplied keys, where you have more control but also full responsibility for managing and protecting those keys.
So you have options depending on your needs and capabilities.
Right. The benefits of doing encryption well are huge. end-to-end protection, meeting compliance, data integrity. But yeah, there are challenges. It adds some complexity, maybe a tiny performance overhead. And the big one, if you lose your keys, you could lose your data forever. So key management has to be robust.
Okay, so encryption scrambles the data itself, makes it unreadable if breached. But what about controlling who can even get near that data in the first place? That seems just as important. Access controls, right?
Absolutely. There are two sides of the same coin. You need both.
Right.
Strong access controls are the other essential foundation. And the guiding principle here is the principle of least privilege, often called POLP. It's simple in concept. Users, application services should only have the absolute minimum permissions necessary to perform their specific tasks. No more.
Just enough to do their job and nothing extra.
Exactly. You want to avoid what's sometimes called shadow access, where identities have way more permissions than they actually need or even realize, maybe inherited from group memberships or old roles. To enforce POLP, we use tools and methods like role-based access control, RBAC. This assigns permissions based on job roles like database admin or billing analyst. It's very common. About 57% of orgs use it. Then there's attribute-based access control, ABAC, which is more fine-grained. It uses attributes or characteristics like the user's department, the time of day, the location, the sensitivity of the data to make access decisions. More dynamic. Around 45% use ABAC.
So more context-aware.
Right. And layered on top of all this, you absolutely need multi-factor authentication, MFA. A password alone just isn't enough anymore. MFA adds extra verification steps like a code from an app, a text message, a hardware token. It dramatically reduces the risk from stolen credentials. It's becoming standard practice, thankfully. About 58% use MFA tools generally, and 74% specifically for securing command line access to the cloud.
Good to see those numbers are high.
Yeah. And managing all these identities and permissions is done through Identity and Access Management, or IAM, systems and tools. These are crucial for actually understanding who has access to what their effective permissions really are, and auditing that access. About 67% rank IAM as a top priority for implementing zero trust, which brings us neatly to the zero trust model.
Zero trust, another buzzword we hear constantly. What's the core idea there?
It really is a fundamental shift in security thinking. The old model was trust but verify. Build a strong perimeter, and if someone's inside, assume they're okay. Zero trust flips that. It says never trust, always verify. Assume that breaches will happen or may have already happened. Assume attackers are already inside your network. So every access request, regardless of where it originates from, must be strictly verified, authenticated, and authorized based on all available context, and access should always follow the principle of least privilege. It's about continuous verification. Never trust, always verify.
Yeah.
That's a powerful mantra. Sounds demanding to implement, though. How widely adopted is it, and is it actually working for organizations in the cloud?
It is demanding, but it's definitely gaining traction. The numbers are pretty striking, actually. Around 81% of organizations say they've fully or partially implemented zero trust, and 84% are actively pursuing it specifically for cloud security.
81% have started? That's higher than I might have guessed.
It is. Now, it's not easy. The top challenges people report are things like managing consistent policies across different clouds. Multi-cloud complexity, that's a big one for 49%. Cost and resource constraints are right behind at 48%. And just getting the necessary visibility is a challenge for 34%.
Yeah, I can see how those would be hurdles.
But the reported benefits are driving adoption. 69% say it's improved their data security. 67% report reduced unauthorized access, and 62% see enhanced threat detection.
So yeah, despite the challenges, organizations are seeing real value.
Okay, it's really clear that encryption and strong zero trust-based access control are absolutely fundamental, the walls and locks. But a truly comprehensive strategy, a complete defense, needs more layers, right? If we're building that multi-layered vault, what other essential practices should people be thinking about to really button up their cloud data security?
Yeah, those are the foundations, but you need more. You really need a holistic approach. One of the very first steps, maybe the first step, is you absolutely must define and discover your sensitive data. You simply can't protect what you don't know you have or where it is. So organizations need to clearly define what constitutes sensitive data for them as a PII, PHI, financial data, intellectual property.
Now, I know your crown jewels.
Exactly. And then you need tools, increasingly automated tools, like data security posture management, or DSPM, to continuously discover the sensitive data across all your cloud environments, storage, databases, PATA services, you name it. Manual processes just can't keep up anymore. Once you find it, the next logical step is to classify and label that data. This is crucial not just for security, but also for access control, for compliance reporting. Implement a clear classification scheme, maybe public, internal, confidential, restricted, and use metadata tags consistently. This helps automate security policies later on.
So find it, then label it clearly. Makes sense.
Then you need to keep eyes on it. Monitor and audit data access. You have to continuously track who is accessing sensitive data, when, from where, and what they're doing with it. Look for anomalies, unusual access patterns, attempts to access data someone shouldn't, large downloads that could indicate exfiltration. This is where tools like SAM security information and event management come in, giving you real-time visibility. You need detailed logging and increasingly UEBA user and entity behavior analytics to automatically detect deviations from normal behavior. We saw about 61% of teams are using real-time monitoring for cloud access grants, which is good.
So constant vigilance over the sensitive stuff. What about the basics, though? Like, what happens if something does go wrong? And tackling those misconfigurations we keep mentioning.
Absolutely essential. Never forget the fundamentals. Prioritize regular data backups and disaster recovery. It's not glamorous, but it's critical. Use the classic 3-2-1 strategy. Keep at least 3 copies of your data, store them on 2 different types of media, and make sure at least 1 copy is offsite, maybe even air-gapped.
The 3-2-1 rule? Still relevant.
Absolutely.
Yeah.
And crucially, don't just have a disaster recovery plan. Test it regularly. Make sure you can actually restore your data when you need to. A plan you haven't tested is just a piece of paper. And yes, back to those misconfigurations. You need processes to identify and remediate misconfigurations proactively. As we said, they're a massive cause of breaches. So regularly scan your cloud environments for things like open storage, weak access controls, missing encryption. Use automated configuration management and posture management tools, CSPM, to detect drift from secure baselines and enforce policies.
Catch the mistakes before the attackers do.
Precisely. And tied to that is addressing vulnerabilities promptly. Run regular vulnerability assessments, maybe penetration tests. Keep your operating systems, applications, and cloud services patched and up to date. Use tools like intrusion detection and prevention systems, IDPS, to spot and block attacks.
It feels like a constant cycle of scanning, patching, fixing.
It is, to some extent. And security needs to start early, too. Secure data and development environments. Shift left, as they say. Scan your code repositories for accidentally committed secrets, like API keys or passwords. Use secure vaults for managing credentials. Scan your CI/CD pipelines for vulnerabilities before deploying code. Implement secure coding practices from the outset. And to really tie it all together, you need to gain full context around data risks. Don't look at data security in isolation. Integrate those insights where is sensitive data, who can access it, with your broader cloud security picture from tools like CNAPPs, cloud-native application protection platforms. This helps you correlate data risks with network exposures, vulnerable workloads, or insecure APIs to see the full attack path.
Seeing the whole forest, not just the trees.
Exactly. And a newer area, but increasingly important, protect AI and machine learning data. As organizations use more AI, securing the training data and the models themselves is critical. Identify sensitive data used for training, prevent attacks like data poisoning or model inference, use techniques like output filtering, anonymization, or differential privacy.
Wow, securing AI data. That's a whole new frontier.
It really is. And finally, never, ever underestimate the human element. Employee training and awareness is paramount. Your employees are often the first line of defense, but also potentially the weakest link if they're not trained on security policies, phishing threats, and how to handle sensitive data properly. Regular, engaging training is key.
That's an incredibly thorough list. It really drives home that cloud security isn't just one thing. It's a whole program, a culture almost. Building that secure vault requires multiple interlocking layers. But, many organizations aren't just dealing with one cloud provider anymore. They're in AWS and Azure, maybe Google Cloud too, plus various SaaS apps, multi-cloud. That adds a whole other layer of complexity, doesn't it? So what does all this mean for someone trying to juggle security across multiple different cloud platforms?
Oh, you've absolutely hit on one of the biggest headaches for security teams today. Multi-cloud is the reality for many, and it definitely brings its own unique security challenges. The most obvious one is just increased complexity. Massively increased. Each cloud provider, AWS, Azure, Google Cloud, they all have their own way of doing things. Different terminology, different APIs, different security controls, different consoles. Trying to implement and manage consistent security policies across all of them is incredibly difficult. It's like, as you said, juggling, but with objects of different shapes, sizes, and weights.
Yeah, I can imagine trying to apply the same rule everywhere when the environments are fundamentally different.
Exactly, and that directly leads to a lack of unified visibility and control.
Mm.
If you have separate management consoles and monitoring tools for each cloud, you don't get that single consolidated view of your entire security posture. It makes it really hard to spot threats that might move between clouds or just to get a clear picture of your overall risk. Blind spots everywhere.
So you're looking at pieces, not the whole puzzle.
Right, and that fragmentation makes it tough to have inconsistent security policies. Defining a single policy for, say, data encryption or access control, and then trying to implement it consistently across AWS IAM, Azure AD, and Google Cloud IAM, it's a huge challenge. You often end up with gaps or inconsistencies. Then there's complex compliance management. Data privacy laws like GDPR have strict rules about data residency where data is stored and processed. Tracking that across multiple clouds in different geographic regions becomes a serious compliance burden.
Nightmare.
It can be. Plus, you've got an increased attack surface again, just by virtue of having more platforms, more potential entry points, and different types of vulnerabilities specific to each provider. And finally, there's often a skills gap and resource constraints. Security teams need specialized knowledge for each specific cloud platform, and finding people with deep expertise across multiple clouds is tough and often expensive.
Wow. Okay, so multi-cloud sounds like it amplifies nearly all the challenges we've already talked about. Complexity, visibility, consistency. It's security on hard mode. So what's the path forward then? How can organizations start to, wrangle this multi-cloud security beast? Are there overarching strategies that help?
There definitely are. It's challenging, but not impossible. The key themes in multi-cloud security best practices really revolve around unification, consistency, and automation. First, strive for centralized visibility and management. Use tools, maybe advanced SIEMs or specialized multi-cloud security platforms that can aggregate data and provide that elusive single pane of glass view across all your cloud environments.
Get everything onto one dashboard.
As much as possible, yes. Second, adopt a zero-trust model consistently. Apply those principles: never trust, always verify, least privilege uniformly across all your clouds. Don't have strong policies in AWS and weak ones in Azure. Consistency is key. Third, encrypt data consistently across all platforms. Use strong, standardized encryption methods for data at rest and in transit, regardless of which cloud it's in. Manage keys centrally if possible, or at least have consistent key management policy.
Uniform protection everywhere.
Exactly. Fourth, given the scale and complexity, automate security processes and compliance checks wherever you can. Use infrastructure as code, policy as code, and automation tools to enforce security configurations, run compliance checks, and respond to threats consistently across environments. Manual efforts just won't scale. And finally, develop a comprehensive incident response plan that specifically accounts for your multi-cloud setup. How will you detect, contain, and eradicate a threat that might span multiple providers? Your plan needs to address that coordination challenge.
Centralize, standardize, automate, and plan. That makes sense. It sounds like the goal is to impose order on that inherent multi-cloud chaos. What an incredible deep dive. Seriously, we've navigated from the basic risks of just being in the cloud through the absolute essentials of encryption and access control, all the way to the really complex challenges of securing multi-cloud environments. The main takeaway for me seems crystal clear. Taking a proactive, data-first approach to security isn't just, a nice to have anymore. It's an absolute necessity for survival in today's digital world.
It really is. And maybe that leaves you, the listener, with an important question to think about. As your own data footprint grows, as it spreads across different cloud services, is your security strategy keeping pace? Are you adapting to match the agility and the complexity of the cloud itself? Or are you perhaps still relying on older, more traditional security approaches that might be leaving critical gaps wide open? Because continuous vigilance, embracing modern frameworks like zero trust, and really focusing on the data, these aren't just best practices anymore. They are fundamentally the pathway to building genuine digital resilience.
That's a great point to end on. Food for thought for everyone listening. Thank you so much for joining us on the deep dive today. We really hope this exploration has given you some valuable insights, maybe some actionable ideas for safeguarding your own digital assets in the cloud. And remember, for comprehensive and robust solutions covering everything from enterprise storage and backup DR to hyper-converged systems, AI servers, security appliances, and cloud services, do check out stonefly.com. And speaking of robust solutions, Stonefly has a pretty compelling offer right right now, a 100 TB immutable and air-gapped SSO NAS that's network-attached storage for just $8,995. That sounds like a really powerful and frankly budget-friendly way to add that extra layer of immutable air-gapped protection for your most critical data backups. Definitely a deal worth looking into. We look forward to our next deep dive with you.